The aim of the present experiment is to determine the coefficient of static friction between the two surfaces in contact, and these two surfaces in contact are the stainless steel and the graphite sheet, and the stainless steel and the Teflon sheet. Now, what is the apparatus required for this present experiment? The first is the adjustable incline. This adjustable incline can be inclined to any suitable position like this. Okay, we can, and the second one is the trolley. Okay, to which a pan is attached, and we can apply certain weight to the pan. The third one is the weight box, and after this, first of all, what is the friction? Friction is the resistance offered to the motion or the tendency of the motion. Now, the second question appears is the what causes friction. Now, every surface has got certain asperities, okay, and so when this is shown in this figure, so every surface has got certain asperities, and when these two surfaces come in contact with each other, these asperities got interlocked with each other, and due to which the force of friction is produced. The second thing is that why we are performing this experiment, what objective would be achieved by performing this experiment. Now, we know that friction is both the boon or bane for the various application. In general, the friction is often associated with losses, but it has got certain positive aspect also, that it helps in walking. All the frictional drives or the mechanical drives are possible due to friction, whether it is the frictional clutch or the brakes, etc. Now, if we determine the coefficient of static friction, then it helps us for the judicious selection of the frictional material, okay, for the various application. Now, one question that also arises that what is the nature of this force of friction, whether it is a fixed force, whether it is a variable force. So, it is a variable force, okay. Its minimum value is 0 and maximum value is mu s n, and it can be beautifully shown by the graph between the effort applied or the force applied and the force of friction. Now, this is the graph that beautifully sum up the force of friction that is on the y-axis and the applied force on the x-axis. Now, if I see this graph, this graph starts from point O. Here, the force applied is 0, and also the force of friction is also 0. Now, when I am increasing the applied force, the force of friction is also increasing, and this trend continues up to point A. This point A is known as the impending state. At the impending state, the force of friction has got the maximum value, and that maximum value is mu s n, where mu s is the coefficient of static friction between the two surfaces in contact, and n is the normal reaction. And once you can say cross this point A, then I enter the domain of the dynamic friction. Then the body would just about to move, or body would move. At this time, the force of friction that would be the dynamic force of friction, and its value is mu d n, where mu d is the coefficient of dynamic friction and n is the normal reaction. And experimentally, it is found out that mu d is 0.8 times of mu s. Okay. So now there are the two methods by which we can determine the force of friction. The first method is called as the angle of repose method. In the angle of repose method, the first I would do is that I would set this incline to the minimum possible angle. Okay, practicable angle. I set it like this. Okay. I would place the trolley on this incline, and I have to determine the coefficient of static friction between this graphite pad and this stainless steel. Okay. Now I would place it on the incline on any suitable position. Then I would mark certain reference point on this incline. I am marking this reference point so that I can visualize the motion. Okay. Now I will gently tap this incline, and I would see whether this block is moving or not. Now this block is not moving. It means the net force that is acting on this block is equal to 0. It means the force of friction does not have the maximum value. Okay. Now I would keep it repeating this or changing this angle of incline. I change it, the angle of incline. So I would change this angle of incline, and then I tap it. And this process would continue until the limiting condition does not exist. Limiting condition means that the block is just about to move, on the verge of the movement. Okay, impending state. Impending state, it is worth mentioning that in case of the impending state, the block would just move and then it would stop. Okay. So I would tap it. I visualize that this block is now moving. Yani it represents my impending state. Now I have to determine the angle at which this block is now moving. Okay. Now the first method is that I can determine it by the, you can say, the angle, you can say, protector mounted on this particular adjustable incline. But it has got certain limitation because it is a mechanical, you can say, apparatus. So it has got certain inherent limitations. The second one is that to measure the angle, I would determine I would mark 2 points on this incline. I would determine the height of these 2 points with a common datum. Let this value is L1, this value is L2, and this value is L1. Okay. And the corresponding horizontal distance between the two is, let A. Then the tan theta is equal to L2 minus L1 by A. And we have also seen that since the block is just about to move, it means the net force that is acting on this particular block is 0. It means the net force that is in the y direction and in the x direction is equal to 0. So here I choose the x-axis is the direction which is along the plane, and y direction is the direction which is normal to the plane. Okay. Now when I put sigma Fy is equal to 0, then the n minus में w cos theta is equal to 0, then n comes out to be w cos theta. Similarly, when I use that sigma fx is equal to 0, then it is the mu s n that is acting upward. Since the block has a tendency to move downward, so the friction always opposes the direction of the motion, so it would act upward. Mu s n is acting upward. The component of the weight, this component of the weight is acting down the plane, w sin theta. So this w sin theta would try to bring the body down the plane, but it would be opposed by this coefficient of static friction, mu s n. And when the net force in x direction is equal to 0, then mu s n is equal to w sin theta. And by using these two equations, the tan theta is equal to mu s. Once I determine the value of tan theta, which I have already demonstrated how I would determine the value of tan theta, I can find out the value of mu s, coefficient of static friction. This is the first method, that is the angle of repose. Now, they are you can say the certain sources of the error. The first sources of error is that if I change this angle of incline in an abrupt manner, not in a gradual manner, then it may happen is that impending state is just, you can say, is just crossed, okay, and then that is one source of the error. To eliminate this source of the error, the incline should be changed in a gradual manner, okay. And the second is that the tap should be gentle and uniform, okay. The second method to determine the coefficient of static friction is called as the coefficient, to determine the coefficient of static friction by loading method, okay. In case of the loading method, what would we do is that we would first of all, we would set this incline at an appropriate angle, okay, at any angle. Then we would place this trolley on this incline, okay. This trolley is such that its one end is connected to the string, and a pan, this is pan, is attached with the string, and this string would pass through the pulley, okay, would pass through the pulley, and on this pan I can apply certain weight, okay, by using the weight box and all those things. Now, I would set this incline to a particular angle. I would place this block on the incline. Then I would mark certain reference point on this incline so as to visualize the movement of the block. Then I would apply certain weight on the incline. The weight should be applied gradually, and this pan, it should be parallel to the horizontal, and this would be possible if these three strings, they are equal in size. Now, I have applied certain load on the pan. Now, I would see whether I have reached the impending state or not. So I would tap it just and see whether this block is moving or not. should be gradual. And I am tapping it. No, it is not moving. So I would change the weight and I would tap it. This is basically a hit and tile method. So I would apply certain load on this pen and I would keep in repeating this experiment till this block is on the verge of the motion, upward motion. And suppose now it is on the verge of the motion. So at this point, the tension in the string is acting upward. Okay. This block has certain weight W. So its component is acting down the plane and that component is W sine theta. Now, since the block has a tendency to move upward, the friction force would act down the plane and its value is mu s n. Okay, mu s n. And since at the impending state, the net force in x and y direction is equal to 0. Here x direction is along the incline and y direction is normal to the incline. So I would draw this. This is the, you can say, the diagram of this particular setup. Here it is the W that is acting downward. It is the W cos theta which is normal to the incline. W sin theta is along the incline in the downward direction. The T is acting upward. And similarly, the N normal reaction is perpendicular to the incline in the y direction. So, since the block does not have any tendency to move in y direction as well as in x direction, so sigma Fy is equal to 0. Now, from this N minus W cos theta is equal to 0. And N comes out to be W cos theta. Similarly, since the block is not moving or on the verge of movement along the plane, so sigma Fx is equal to 0. So T minus में mu s dash N minus में W sin theta is equal to 0. Here T is the tension in the string, mu s dash is the coefficient of static friction between this block and the stainless steel, and W is the weight of this block, and theta is the you can say the angle of the incline. Now we can determine the value of the T, the tension, by considering the equilibrium of this pan. So T is acting upward. The P, that is the effort applied or the load applied. This load includes the weight of this pan also, that is acting downward. Since it is not moving in the y direction, it means the net force in the y direction is equal to 0. And T minus में P is equal to 0, or it means T is equal to P. The tension is equal to the load applied, P. So when I combine these two equations, then mu s dash is P minus में W sin theta upon में W cos theta. Now we have determined the coefficient of static friction between the two surfaces in contact. The first by the angle of repose method, that is mu s, and the second one is by the loading method, that is mu s dash. Now the percentage error can be found out in the absolute terms is that mu s dash minus में mu s upon में mu s into में 100. Now we can perform this experiment either by changing the angle of incline or setting the incline at different angle. Okay, that is the first method. The second method is that we set the angle of incline at a particular angle, but we are changing the weight of this block trolley by adding certain weights into this. Okay, so this method can be performed in these two different, you can say, procedures. The first is that we are changing the angle of incline and we are applying the load on the pan so that the block is just on the verge of the movement. That is the first method. The second is that we are setting the incline at a particular angle, but we are changing the weight of this block by adding or removing certain weight to this block. Okay, and we would find out the percentage error, okay, for the different set of reading, and the average value of the percentage error would be found out. Thanks.